Hi everybody, these are the notes for sum and difference of cubes. So we're going to start by reviewing the difference of squares, which you'll remember is a squared minus b squared. So anytime we see a square number minus another square number, we know that it's going to be a plus b times a minus b. And the reason that that happens is because if you think about like a plus b, a minus b, a squared, this would be negative ab and positive ab, which would cancel, and this is going to be negative b squared. So we can see that if we were to multiply a minus b times a plus b, we'd get back the a squared minus b squared, which is there. So if we ever want to break it down, we can work backwards. Let's just start by listing some square numbers. So like 1 squared would be 1. So 1 is a square number. 2 squared would be 4. 3 squared would be 9. 4 squared would be 16. 5 squared, 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. Some other common ones are 20 squared. So 20 times 20 would be 400. Those are about as big as it gets. You can do the rest of them on your calculator if you need to. But definitely those are going to be the ones that we're looking for here. So if I have x squared, I know that x squared is a number because it's is a square number because it's x times x. And I know that 4 is a number because it's 2 times 2. So I know that this would be x plus 2 and x minus 2. That's going to be my answer for number 1. For number 2, I'm going to check. I'm going to say, okay, I know that this could be 3y times 3y. And I know 16 could be 4 times 4. So I know this is 3y plus 4, 3y minus 4. And I could always double check all of these using the box, but I'm pretty confident here. I think you guys remember this too. So I know 100 could be 10h times 10h, and then this one would be 7k and 7k. So I have 10h minus 7k and 10h plus 7k. So that one works there. And then for number 4, 72 is not one of the square numbers that I mentioned, and neither is 2. So I'm going to look for a GCF, something I can factor out. So I know they're both divisible by 2. So I'm going to put that 2 out in front. And then that would leave me with 36c to the 4th minus 1. And I can see here that this is a square number. So 6c squared times 6c squared. And I know 1 is a square number. It's 1 times 1. So I'd say I'd bring that 2 straight down. And then I'm going to have 1 positive, 1 negative, 6c squared plus 1, and 6c squared minus 1. So I can put that GCF out on the outside, and then it will work exactly the same. Okay, so just make sure you put that GCF out there. So difference of squares is pretty straightforward. We just have to kind of recognize that each number is a square. The reason I started by talking about the difference of squares is that I wanted to talk about something that, like, this is just a rule that we memorize. And the difference of cubes is unfortunately not any better. The difference of cubes and the sum of cubes, for instance, we can actually, or for example, we can actually do the sum and difference here. If we tried to do x squared plus 4 with the difference of squares, this would not work. Make that like a whole phrase there. Does not work. And the reason is because we need those ones to cancel. We need them to be minus. Cubes are a little different because there's 3 of them. And so we have a new formula. So the difference of cubes says that if we ever have a cube something like this, plus another cube. Then we can take the cube root plus the other cube root. We can square it, subtract it, multiply it, add, and square it again. And these are kind of funky because they're almost exactly the same, right? So the a's are the same, the b's are the same, a squared is the same, ab is the same, and b squared is the same. The only difference is the sign. And we came up with this like mnemonic. So a mnemonic is a way of remembering something, and the mnemonic is SOAP. So it stands for same, opposite, always positive. So it's a way to remember the signs and what order they go in. So if I look here, if I'm doing an addition problem, then the first sign is the same. The second one is the opposite, and the third one is always positive. So we could see if it's positive, then we want to do positive, same, opposite, negative, and then always positive. The same is true for minus. So if it's minus, it starts with minus and then does the opposite, and then the last one's always positive no matter what. So we can use this mnemonic to remember the signs of the pluses and minuses. So we're going to start by listing the same cube numbers. So something like 1 cubed would be 1. I'll try not to draw a cube for every single one. 2 cubed would be 8. 2 times 2 times 2. 3 times 3 times 3 is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed, I can't remember. I think it's, nope, I don't know. You'll have to look it up. So I have these ones. These are pretty much the biggest that they go. So I just want to, like, take a look and see if there's any that I can recognize. So let's start with like a super simple one that just follows the rules. So if I have x to the third, and I have 64. I know that both of those are cubed numbers. So what I'm going to do is I'm going to take the cube root of each of them, right? What I'm calling like the base. So the cube root of this would be x, and the cube root of this would be 4, right? So these are my cube roots, right? X and 4. And that's what I'm going to use in my formula. So this is the difference. So I have a minus b, a squared plus ab plus b squared. And the way that I remember is kind of like ombre. I start with ab, like ombre hair is like really what I mean. So like I start with a and b, and then I know that it's a squared, and then it's sort of a and b together a little bit, and then b squared. And then I use same, opposite, always positive. So the first one's the same as the problem, so minus. Then I'm going to do the opposite, and the last one's always positive. So in this problem, like x is going to become a, and b is going to be 4. So I would have x minus 4, and then I would have x squared minus, and this would be like x times 4, so 4x. And then b squared would be 4 squared, which is plus 16, like that. And this is the factored version of my cube, which I started with, this one here. So I know it feels like a little clunky for a lot of work. Like, it doesn't really do that much. I totally understand. If we have this, where this leads to is that if I have this, I can like factor it, and I can find the solutions for it. So that could be helpful. Okay, so we'll try this one. This one is addition. So I know it's a and b, a squared, ab, b squared. And I know it's addition, so it starts with addition, switches to subtraction, always positive. And then I'm going to take the cube root of this. so that turns into just y, and the cube root of this turns into just 2. So I'm going to have y plus 2, and then y squared minus 2y, y times 2, remember, and then plus, this is 2 squared would be 4. So this would be my answer here. Right. So not too tricky once you get the hang of it, just a couple pieces to keep in mind. And that memorization piece is a lot. So I would recognize this one is, I'm going to take the cube root of it. So the cube root of 8 is 2, and the x cubed would just be x. And then the cube root of 27 is 3. So, and this is addition. So I have a squared, ab, b squared, parentheses, parentheses. I have plus, so that plus sign is going to go here. It's opposite, and then always positive. So for this one, I would have, this is going to be a, this is b. So I have 2x plus 3. And then for my a squared, I have 2x, and 2x is being squared. The whole 2x is being squared. Which means that squared is going to go onto both pieces. It's going to make 4x squared. Right, so the 2 went on here, and the 2 went on here. And then minus, and a is 2x times b, which is 3. It's going to make 6 x's. And then b plus, and then b squared would be 3 squared, which would just be 9. So this is my final answer. So that one looks like a little funky because of the square. You just want to make sure that you're squaring the whole thing. But that's going to be my answer. For number 3, 16 is not one of the cube numbers that I listed. Neither is 54. So I'm going to look for a GCF. Something I know I can take out of both of these is a 2. So as well as I see x to the 4th here and an x there. So I'm going to take an x out because I can take an x out. So I'll leave the 2x on the outside. And then I'm going to have 8. And this will make 3 and cancel with that. So I'll have x to the 3rd minus, and then 54 divided by 2 is 27. And these x's will cancel. I'll left with y to the 3rd. So now I can see that I have a cube root here that I can make, which would be 2x. And I have a cube root here that I can make, which would be 3y. And that 2x is going to come straight down. I'll put it in that same color so that we know where that came from. So when I have my formula, I'm going to do a and b. So I have a squared, a b squared. And it's the same, opposite, always positive. Okay, so in this case, a is 2x and b is 3y. So a is going in here as 2x squared. The whole thing is being squared. So I would have 4x squared. And then for AB, a is 2x and b is 3y. And then b squared would be 3y squared. So I would have plus sign. I have 3x and, or 2x and 3y would make 6xy. And then 3y squared makes 9y squared. So I'd have this crazy